everyone. My name is Alex Hoyos, and I'm here with Lena Nance, and we're team WEBONICS, which stands for Web-Based on Semiconductor Integrated Circuit Simulation Development. We're working alongside Robert Davis and Frank Kolenko from On Semiconductor. So a little bit about On Semiconductor is they have locations all over the world, including fabs. They spin off of Motorola, and each location specializes in different things. The Rhode Island location specializes in switch mode power supplies and drivers, while they also specialize in audio. The Rhode Island is automotive, communications, computing, medical, and many more. So On Semiconductor, I think it's working now. On Semiconductor came to us for Project Motivation, where they're trying to do something very different. They're trying to be pioneers in this, and what they're trying to do is implement the simulation environment on their website. So this will solve interfacing issues between customers and producers, will shorten simulation times, and solve convergence issues, because often when a customer is interested in an integrated circuit, they want to simulate it on their own, and On Semiconductor may provide a net list, but using different platforms or programs may cause convergence issues or just overall errors. So by having the simulation online, customers can easily just pretty much play with the integrated circuit and see if it's something that they're looking for. So right now, this is pretty much what the On Semiconductor webpage looks like. You don't have to look much into it, but there's a lot of steps to it when you want to find an IC that works for your application. So you go on the website, you select what you need it for, in this case automotive, and you go through many design notes and specs, and then it takes you to a different webpage, another webpage such as this block diagram where you keep on building your ideal integrated circuit. So this could all be improved or simplified by having a simulation online where the customer is also able to verify that the IC they're looking for is right, because doing this online would take up to minutes instead of days talking back and forth from producer to customer. So the overall implications for the company, as I said before, since On Semiconductor are being pioneers in this will greatly streamline the process, overall save time. It could go from days to minutes. It will drive customer satisfaction and sales, since it's something that nobody else is doing right now. And now I'm going to hand my clicker to Lena, just to kind of tell you a little bit more about the scope for our project. Here you go.
Thank you, Alex. So to those ends, our project has been divided into two different parts, two different phases. In the first phase, we're going to start simulating a buck converter. And just like Team Infineon discussed earlier, a basic buck converter can step down a DC to DC voltage. For instance, ours is an automotive buck converter, so we'll step down a 12-volt battery down to roughly about 3 volts, which can power other devices in your car's cabin, such as the LED screen and the chair, the motors in your chair. And then our second phase is to create a PCB design that shows an application of the buck converters that we've simulated that will then be used to generate interest in this platform. And speaking of platforms, we're dealing with System Vision, which is an affiliate of Mentor Graphics, and they provide an online simulation software which both customers and producers, such as On Semi, can go to in one spot, and then the customers can play with their designs and get feedback going both ways from the customer and the producer to just cut out the time of emails, downloading software, and all of the separate steps that exist right now. So a little bit more background about the buck converter. Just like Infineon, we have a standard buck converter right here, and the voltage output is directly correlated, proportional to the duty cycle. Of course, On Semiconductor has a lot more complicated circuits involved in their integrated circuit buck converters. So our team, while simulating, has divided up the work by creating sub-circuits every week, just to ensure that each section of the project is going to work together as expected. So as you see here, there's just 3 examples we have of a soft start, an error amplifier, and an oscillator. And all of these circuits together, go create our larger buck converter schematic, which simulates kind of the real world application of the buck converters in practice. And we see here there's the error amplifier, the soft start, the oscillator, and we've actually joined it with flip-flops, other amplifiers, a bootstrap here, and then of course here's the basic buck converter that I've shown you on a previous slide. Now this is what we see when we're designing, but the next phase that the customer should see is actually something more like this black box here. It's more approachable, it's kind of less intimidating to deal with, and it will be easier for them to just change a couple aspects of the product, and then they can adjust their loads, their resistors, and their filter according to different specs needed in their industry that they're working for. Even it can meet international standards. And of course, this buck converter is just one example of the buck converter family, but other buck converters will have more pins, more inputs that can be changed by the customer. So after that, our remaining technical challenges are to reduce the simulation time. Right now, it's probably about like 10 minutes to simulate. We would like to get that down as low as possible, just to keep the attention of the customers. And then, of course, after that, we're going to design the printed circuit boards, which can then show an application of our buck converters. And we're going to assemble the boards and craft them such that they can be transported from place to place, generate interest through marketing events, trade shows, and recruiting events. And that concludes our presentation. We'd like to extend a special thanks to our technical directors, Frank and Robert Davis, who take some time out of their schedule just to teach and mentor us. It's been an integral part of our learning development. And we would like to thank Dr. HCOSEC for putting this all together and giving us a great life experience. Thank you so much.
Thank you.